Welcome to the AI Checkpoints. Today we're diving into something really exciting, GLM 4.5. This is a brand new frontier model, and it's genuinely pushing the boundaries of what AI can do. Our mission today is basically to unpack how GLM 4.5 excels in reasoning, coding, and maybe the most intriguing part, its agentic abilities. Now, if you're not familiar with that term, agentic abilities, think of it like AI moving beyond just, understanding or generating text. It's about actually taking autonomous action and doing things on its own. It's a pretty big step.
It really is. And just to give a quick overview right off the bat, this new model comes in two main flavors. You've got the full power GLM 4.5, built with a massive 355 billion total parameters, huge. And then there's a more, let's say, compact version, GLM 4.5 Air, which has 106 billion parameters, still very powerful. What really jumped out at me from the research paper is this unique approach they have to hybrid reasoning. They built in a specific thinking mode for the really complex tasks, the ones that need deep processing. But alongside that, there's a non-thinking mode designed for, instant rapid responses. It seems like a really clever way to balance being thorough with being fast.
That is a fascinating setup. For a long time, the big goal, the sort of holy grail for large language models, has been getting to human-level cognitive abilities across all sorts of domains, not just being good at one specific thing. We're talking general problem-solving, common sense, even the AI improving itself, getting closer to how we think.
Exactly, you've hit the core goal there. And if you look back, say, the past 5 years, we've seen incredible steps. Models like OpenAI's GPT-3, they really opened the door, showing how much common sense knowledge an AI could soak up. Then more recently, models like o1, which really pushed reinforcement learning, showed big jumps in reasoning skills, coding, data analysis, complex math. They were essentially teaching these systems to think before they respond. But the big challenge was always generalization. You might get a model that's amazing at code or other that's brilliant at math, but none truly unified all those strengths. It was like having specialists, but no real generalist tying it all together.
Right. Okay, so with that context, what does GLM 4.5 bring to the table? How does it change that picture?
Well, this is what's so interesting. GLM 4.5 seems to directly tackle this unification challenge head-on. Their whole aim is to bring these high-level, diverse capabilities, reasoning, coding, agentic stuff, into one single cohesive model. And that's a massive step. The numbers seem to back it up, too. Across 12 different benchmarks covering agentic tasks, reasoning, coding, GLM 4.5 ranks third globally, and its smaller sibling, GLM 4.5 Air, is right up there as sixth.
Wow, third and sixth.
Yeah, and it's not just the ranking, it signals a potential shift. Many top models get there by being hyper-specialized. GLM 4.5 is hitting the top tier by unifying these things, which many see as a much tougher nut to crack. It feels like real progress towards more general AI.
Okay, let's definitely get into those agentic tasks then, because like you said, this feels like where things get really practical. Moving beyond just answering questions to actually doing stuff, interacting with systems, making things happen. What makes GLM 4.5 good at this?
Precisely. It's specifically optimized for these agentic tasks. One huge factor is its massive 128K context length.
128K, what does that mean in practice?
Think of it like giving the AI a working memory that can hold every single word of, say, a 100-page book all at once. This lets it handle incredibly long, complex conversations or multi-step jobs without losing the plot. Plus, it has native function calling built in.
Okay, function calling. That means it can use other tools.
Exactly. It can directly interface with external software APIs. Essentially, it can press buttons or send messages in other programs. It gives it hands, in a way.
Now that's where it gets really interesting. So how does it actually perform compared to other big models in these real-world type scenarios? Using tools, browsing the web, that sort of thing.
Yeah, the benchmarks here are pretty revealing. On tests like TempBench and BFCL-v3, says the Berkeley Function Calling Leaderboard, a tough test of using tools GLM 4.5 actually matches Claude 4 Sonnet.
Matches Sonnet. That's impressive.
It is. And then there's web browsing. That's a classic agentic task, right?
Yeah.
Needs complex reasoning, using tools over multiple steps. On the BrowseConf benchmark, which is really challenging, GLM 4.5 gets the right answer 26.4% of the time.
Okay. How does that compare?
Well, it clearly beats Claude 4 Opus, another big Anthropic model, which got 18.8%. And it's very close to a4 Mini Highs, which scored 28.3%. So it's right up there with the best. And it really makes you think, doesn't it? Imagine the possibilities when AI can just reliably navigate the web for you, finding info, completing tasks. That's a huge jump in practical use, closer to that truly smart digital assistant idea.
Definitely. But beyond just acting, how well can GLM 4.5 really think? Because, acting is one thing, but true reasoning, figuring things out, that feels like the core of intelligence.
Absolutely crucial point. And that's where their dedicated thinking mode comes in. In this mode, it can tackle really complex reasoning problems, math, science, logic puzzles. For instance, on the Math 500 benchmark, which is advanced multi-step math problems, it scores a remarkable 98.2%.
98%.
And on
Wow.
EME24, that's a tough math competition for high schoolers. It hit 91.0%. These aren't just basic calculations. They need deep understanding, sophisticated problem solving, sometimes multiple steps of abstract thought to get the answer.
So it's not just recalling facts or formulas, it's genuinely figuring stuff out, like solving a new puzzle each time.
That seems to be the idea, yes.
That's a big deal. And that ability to reason must be incredibly useful for something like coding, which I know a lot of our listeners are really interested in. How does GLM 4.5 stack up there?
Oh, it absolutely excels at coding. We're talking the whole spectrum,
Hmm.
from building entirely new projects from scratch, just based on a description, to acting like an agent to solve tricky coding problems inside big existing code bases. And crucially, it's designed so you can easily combine it with coding toolkits developers already use, like Claude Code, RuCode, CodeGeeks. It slots into existing workflows.
That makes sense for adoption. What specifically stands out to you about its coding skills?
For me, what's really fascinating is its full-stack development capability. This isn't just spitting out code snippets. It can create entire web applications. Think about that. Handling the front-end UI, managing the back-end database, even deploying the app,
The whole thing.
the whole thing. And apparently the interfaces it designs aren't just functional, they look good too. They align well with human design sense. And it doesn't stop there. It's also surprisingly good at generating presentation materials, slides, posters, especially when you let it use its agentic tools to go find information online first. It can pull context and make quite polished presentations almost on its own.
That's pretty wild. So, wait, it could build an app and then make the PowerPoint slides about the app it just built?
Essentially, yeah, that level of integration seems possible.
Okay, that's next level.
And the performance data backs this up too. When they tested its agentic coding, GLM 4.5 won against Kimi K2 53.9% of the time. And it had an 80.8% success rate over Qwen 3 Coder across 52 different coding tasks, front-end stuff, data analysis, complex algorithms.
Mm.
But here's a key stat. It had the highest average tool calling success rate at 90.6%,
Higher than?
higher than Claude 4 Sonnet, which was at 89.5%. This shows it's really reliable when the coding task gets complex and needs to correctly use various tools multiple times. That reliability is huge.
Okay, this all sounds amazing on paper, theory, benchmarks. But can you give us some really concrete examples? What can it actually make? Like, what does making an interactive mini game look like in reality?
Yeah, absolutely. The paper has some great demos that really show it off for what they call artifacts. It can generate pretty sophisticated standalone code,
Mm-hmm.
interactive mini games, yeah, physics simulations,
Mm.
even complex UIs like a to-do list with drag and search. They mention things like Flappy Bird style games, 3D maze runners, fully functional, generated by the AI.
Seriously, it can make Flappy Bird from scratch, just like that. That's mind-blowing.
It seems so, yeah. Pretty impressive stuff. And then there's this model native agent specifically for slides creation. Imagine just asking it for a design or maybe uploading document, and the agent goes off, searches the web, grabs relevant images, and puts together professional-looking slides. Think about asking it to make a presentation on, I don't know, Tadej Pogacar's achievements.
Huh.
Or maybe turning a dense PDF research paper into a clear slide deck for a meeting.
That would save so much time. Wow. Okay, incredibly practical. And what about that full stack development? Can it really build a whole website from just a few prompts?
So for full stack development, they describe a coding agent powered by GLM 4.5. You give it a basic website template, a boilerplate, and then just by talking to it, describing what you want, you can create an entire website. You can refine it, add features through back and forth conversation. It makes coding really iterative and smooth. They give examples like generating a Pokemon Pokedex live site or a cyberpunk card AI generator just from descriptions. It really seems to turn ideas into reality pretty quickly.
This is all genuinely incredible tech, but how? How does it actually do all this? What's under the hood making these reasoning, coding, and agentic abilities possible?
Right, the how. If we connect it back, it involves some really interesting architecture and training choices. Primarily, GLM 4.5 uses what's called a mixture of experts, or MOE architecture.
Mixture of experts. Okay,
Okay.
what's that in simple terms?
Instead of one enormous brain trying to do everything, a MOE model has lots of smaller, specialized expert networks inside. When a task comes in, The model smartly routes different parts of the problem to the best expert for that piece. This makes things much more efficient, both for training the model initially and when it's actually running and generating responses. It saves a lot of computation. And interestingly, the research also found that deeper models with more layers actually showed better reasoning ability, which isn't always intuitive. You might expect diminishing returns.
Huh. So it's like having a deeper team of specialists leads to better overall thinking. Okay, makes sense. And how does it learn all this stuff? From browsing the web to writing full apps, what's the training process like?
It's immense, a multi-stage process. It starts with pre-training on a truly massive data set, 15 trillion tokens of general data.
15 trillion, how much is that?
It's hard to grasp, but think of it like reading the entire text of Wikipedia, maybe 2,000 times over, something like that. It builds a huge foundation of general knowledge. After that, it gets a more focused diet, 7 trillion tokens, specifically of code and reasoning data. And then beyond those huge initial stages, they have more specialized training stages to really fine-tune its performance for those key things like agentic tasks and coding.
Okay, that's a staggering amount of data and very structured approach. What about the reinforcement learning part you mentioned earlier for the agentic skills? How do they teach it to act reliably in these complex multi-step situations?
Right, the RL part is crucial for the agent stuff.
Yeah.
For models this big, they actually develop an open-sourced and RL infrastructure they call Slime. And Slime has some key innovations to get around the usual bottlenecks you hit when training complex agents. For example, it has a flexible hybrid training architecture. This means it can do standard synchronous training, but also asynchronous training.
Why is that important?
Because collecting data for agent tasks often means interacting with slow external systems, right? Like waiting for a web page to load. Asynchronous training means the GPUs don't sit idle waiting. They stay busy, maximizing efficiency. And another big thing is its decoupled agent-oriented design. This basically separates the data collection part from the actual model training part. So gathering that slow interactive data doesn't block the training process. This is fundamental for speeding up training for those really long horizon tasks where an agent needs tons of steps to reach a goal.
Got it. So it's engineered from the ground up to be super efficient at learning these complex, drawn-out actions that agents need to master.
Exactly. That post-training phase using reinforcement learning is absolutely vital. It's specifically aimed at boosting those agentic skills, deep search, advanced coding, using tools effectively. It involves fine-tuning on specially curated reasoning data, synthesized agent scenarios, and then the specialized RL phase. And it does raise a fascinating question. Just how much more autonomous, how much more capable can these agents become with these kinds of targeted, efficient training methods? The potential seems enormous.
It really does. This has been an incredible deep dive into GLM 4.5. We've covered its reasoning, its coding power, those transformative agentic abilities. For listeners who are now really curious, maybe want to try building that game or getting help with a presentation, where can they get started? How can they try GLM 4.5 out?
Good news is, it's pretty accessible. You can chat with GLM 4.5 right now on the Z.ai platform. Just select the GLM 4.5 model option there. For developers wanting to build with it, the Z.ai API offers OpenAI-compatible interfaces for both GLM 4.5 and the Air version. So integration should be fairly straightforward if you're used to that ecosystem. And for folks who want to really get under the hood, maybe run it locally or build it into their own custom agent frameworks, the actual model weights for both GLM 4.5 and GLM 4.5 Air are publicly available. You can find them on Hugging Face and ModelScope.
Great. So multiple ways to access it.
Yeah, they've made it available for a wide range of users and developers.
So there you have it. GLM 4.5 isn't just, another small update in AI. It really feels like a significant leap towards truly general AI agents. It's pushing the boundaries, showing incredible skill in reasoning, coding, and taking these complex autonomous actions across a huge range of tasks.
It absolutely challenges us to think differently about how AI will integrate into everything, how these unified capabilities might reshape entire industries, even just our daily workflows. Tasks that needed multiple specialized tools or even a lot of human effort might soon be handled by a single powerful agent like this. It's a compelling glimpse into AI's future.
Really fascinating stuff. Hit like and subscribe if you like the content. See you next time.